Let's discuss the distinction between gravity, mass, and weight. Mass is a measure of how much an object resists being accelerated. The more mass it has, the more difficult it is to accelerate it. It is also a measure of the amount of matter in the object. It does not depend on where the object is. The amount of matter is going to be the same. Despite the fact that we use them interchangeably in everyday language, mass and weight are different. Weight is a force, mass is not. Mass is a quantity of matter. Weight, we also call it the force of gravity, depends on the mass. The mass does not depend on the weight. The weight depends on the mass. The gravitational force or gravity pulls harder on greater masses. The force of gravity, the weight, depends on where the object is. For example, the gravitational pull is different at the surface of other planets. It is different at the surface of the moon, for example. It's about 1/6 of the pull it exerts on Earth. Now, when you are at the surface of the same planet, the acceleration due to gravity, when there are no other forces present, is the same for all objects. Now, equation-wise, the gravitational force, we write it as F sub g, or W, m times g, where g is the gravitational field value or acceleration due to gravity at the surface of a planet. That's what g is. But this force is actually due to the mutual attraction of two objects. The gravitational force is one of the fundamental forces of nature. It is a force between any two masses in nature. Any two masses are going to attract each other with that gravitational force. For example, if the blue sphere here represents a student and the red sphere represents the Earth, the gravitational force is a force between the student and the Earth, and it is given by this expression. G, which is a different constant than this. This is more of vector, this is a constant. Mass of the student times mass of the Earth over the distance separating the center of the Earth to the center of the student. When a student is sitting at the surface of the Earth, that distance is basically the radius of the Earth. What we find through this expression in magnitude is going to be equal to what we find in this expression in magnitude. This gravitational force here that we wrote this way is a manifestation of the mutual interaction between objects at the surface of a planet and the planet. That's what the gravitational force is. But it is the same force that the student is going to experience in interacting with other masses. Student blue is going to attract student red. Student blue is going to attract and be attracted by the moon. Student blue is going to attract and be attracted by the sun, etc. It's a universal attractive gravitational force.